All right, welcome everyone. Thank you for joining our Tech Talk today. Today we have Chris Thompson here again with us, and they're going to be talking about prompt engineering. So thank you for being here and take it away.
All right, thanks. Yeah, hi everybody. So this is going to be a little bit different. So this is kind of a brand new topic, and I'm sure can be quite controversial too. So I'll address some of that along the way. I know people have pretty strong opinions about all of this stuff. So yeah, feel free to shoot questions. During the presentation, I'll try to answer them as best I can. Again, I don't have all the answers because all the answers haven't even been figured out yet, right? So agenda, we'll do an intro to LLMs. We'll talk about prompting basics, and then we'll talk about a couple prompting techniques and do some examples of those and show some examples of those. Some of them are difficult to show here because we'd have to build an entire system, and I was too lazy to do that for this talk. So, or shouldn't say lazy, I should say busy. But maybe in the future I can do a talk on building an actual system out using this stuff. Okay. So what are LLMs? Large language models. The basic idea behind an LLM is we're predicting, the likelihood of a sequence of words, right? And so if you know machine learning, which I'm sure all of you at least have heard of machine learning at this point, the idea is to predict some result, right? Like, so you get some input, you give some output, and that's what language models are doing, but in the context of language. So they're predicting maybe what will come next in a sequence of words, but there's also a lot of other tasks that they can be fine-tuned to do: summarization, question answering, all of this kind of stuff. And what's considered a large language model, right? These kind of emerged in the late 2010s with Google's BERT, right? The BERT model came out. Attention is all you need was a paper that was written, and I don't have the link with me, but if you Google it, you'll find it. Right, so if you read through that paper, this attention mechanism was developed, and it blasted off. Like, it completely changed the face of natural language processing, NLP. The idea behind these models, right, and why they're so powerful, well, one of the reasons why they're so powerful is not just the architecture, but the amount of data that they're trained on. So if you've probably heard of the GPT models at this point, right? We have ChatGPT. The original ChatGPT was based on a model called GPT-3, and GPT-3 was trained on an estimated 45 terabytes of data, which takes a massive amount of compute to get these models trained up. These models are called generative models, right? So it means that they're actually creating content based on things that they already know, right? So whatever text they were trained on, they have this knowledge graph. And you can think about it as like if we took a book, right, and we compressed, or if you just take a text file and you compress it down, that information is still there. It's just in a smaller form, right? Thanks for posting that paper. It's just in a smaller form. And so you can think of like taking 45 terabytes of data and compressing it down, but being able to search across that data, and not just search across that data, but create new content from that data. So this mapping that this model has, it understands, quote unquote, I'm going to use a lot of these types of words. I'm not saying that it's understands in the way that we do, but it has mapped out some form of understanding mathematically to be able to produce results that we're getting from things like ChatGPT. And again, like I said, they can be used for translation, summarization, question and answering, and among other tasks, right? Classification now and other things with these larger and more generalized models. But here you have this timeline, right? And I thought this is interesting. This is starting to pop up, and it's NLP's Moore's Law. So if you're not familiar with Moore's Law, it was that every, year or whatever, the number of transistors, and I'm going to butcher this a little bit because I can't remember off the top of my head, but the number of transistors is like doubling. The amount of compute power essentially is doubling every year, right? The computers are getting more and more powerful. Now that's kind of like controversial too. That started to taper off a bit. But going with that same idea, they're now talking about like this NLP's Moore's law, right? So we got the Google transformer model, the original BERT model, over here, right? In 2018, OpenAI brought out GPT around this time too. And those are a fraction of billions of parameters. And parameters are just, if you think of like y equals mx plus b, right? You have a single parameter in that equation. As you add more, right, like x1, x2, x3, those are the parameters. So in this case, we have millions of those parameters, and that's a loose way to think about it. But essentially, that's what we're talking about, is a mathematical equation with these parameters, right? And the more parameters you have, right, the more freedom you have to adjust to different data sets, and you end up with the more. It turns out the larger the model is, they've found you can squeeze better and better results out of these models. So parameters have been a big focus. Now that's starting to change too, right? Like they're starting to say, well, if we can just get good data sets, right? Or even augment, which we're going to talk about later, like augment the outputs of these models, that we can actually, we don't need billions of parameters, right? We can use smaller models and still get decent results out of these systems, which is great, because hosting a model that is 170 billion parameters is quite large. And we don't have, as just you and me don't have access to that. Well, maybe somebody does. I don't have access to that compute power, right? And so there's a lot of people experimenting with putting models using techniques like quantization to shrink these models down and actually get them to run on like CPUs. So we could see this shrinking of models, which doesn't mean they're less powerful. It just means that that we're able to run them in places like maybe on our cell phones and places like that, right? And these are techniques pulled from deep learning. This is all based around deep learning. So I've heard a lot of this thing where like, oh, ChatGPT isn't that great, right? What's so great about ChatGPT? And on the surface, it seems like, okay, it's cool, right? It's kind of novelty, but what can we do with this, with ChatGPT, besides just like have conversations and like do stuff? Because everybody's like, well, it hallucinates and it, makes stuff up, or it's not good at math, or like whatever the case may be, right? And as we go along, we've started to realize that the better that we have to learn to speak to it. So, give it instructions that you can get better and better results out of. So just a little, if you haven't heard of ChatGPT, I highly doubt everyone here hasn't, because you're here learning about prompt engineering, but just to give some background. So again, based on this GPT architecture, right? And GPT stands for Generative Pre-trained Transformer. Transformer is the technique or the architecture used to create this model. You can actually have a great link that I'll drop. It's a visual representation of how transformers work that I refer to quite frequently. So I'll dig that up. I'll dig that up after this talk. I'll share it. Oh, wait, nope, found it. Yes. If you don't use bookmarks like a library, you really should. I keep everything in like crazy amounts of bookmark folders, and I found it really helpful. So that's how I was able to locate that so fast. There you go. So this will show you more or less in a visual representation how a transformer works. It's a little lengthy, so you probably can't read it right now, but definitely stick that in your bookmarks. Save it for later if you're interested in learning about transformers. So they're trained using techniques pre-training, it was trained using pre-training and fine-tuning using RLHF, or reinforcement learning with from human feedback, right? And this technique, reinforcement learning, has been around for quite a while. Right, it's a kind of an older technique. They're starting to talk about classic machine learning, which is crazy because, yeah. But anyway, so this is but combining these two techniques has, advanced what these models are capable of, and hence that's where ChatGPT comes from. Is this idea that humans are giving feedback to the model to tell it, and this is during the training process, to tell it, hey, this was good output or this was bad output, right? And it goes and changes itself based on this feedback that it's receiving. And so using this technique is actually is like the superpower behind ChatGPT. Again, it's made up of, and we don't know for sure, it's closed, right? It's proprietary, but it's made up of billions of parameters. It is a massive model. Now, it's recently come out that ChatGPT 4 is actually not a single model, but a bunch of smaller models together, forming a system, which a bunch of people are really upset about and questioning the whole, advancement of NLP. And I'm just like, it just makes sense. Like, ensemble models have been around for a while, and it's, it's a natural advancement. So I'm still impressed, and you should be too, honestly, because this stuff is crazy. So, all right, we've talked about LLMs. I want to look, are there any questions that were in the chat that I can answer before we keep going? Are we good?
There were some, let's see. So I think Sherry asked about the Moore's Law and what's the difference between the NLPS Moore's Law and just Moore's Law?
Right. Yeah. So NLP Moore's Law is not really like an official thing. They're just comparing it to Moore's Law to try to explain the advancements that are being made in NLP. Right. So like Moore's Law relates to compute power, whereas the NLP law relates to the power of these actual models that are coming out. So they're two separate things. They're just using it to try to, kind of explain to people just how advanced these models have become.
Got it. Thank you. Mm-hmm. And then another question, what's an ensemble model?
Yeah, I figured that would come up, and I probably should have explained that. An ensemble model is nothing but using multiple models to get an output. So instead of sometimes it's easier to have a couple models that are trained on one specific task rather than one large model that needs to do multiple things. Okay, you get better results that way, and that tends to be true in all of machine learning, including with these models, which is something to keep in mind when you're trying to use ChatGPT. So instead of telling ChatGPT to do everything at once, right, it's easier to tell it to do one thing and like chain those commands together. So do this thing, give me that output. Okay, now I'm going to say that do this next thing, use the output from the previous thing, right? Having it concentrate on one thing at a time actually gives you better results than trying to say, do all of these things and give me the results. A lot of times that's where you get the hallucinations and things like that. So it's a way to mitigate some of the risk that comes with hallucinating or these models hallucinating. But ensemble models are just a bunch of models put together to simulate one single model. Yeah, and model hallucination, right? Hallucinating in the context that we're using it means that it tells you something that's not true. So you say, like, tell me the color of the sky, and it says purple. And you're like, that's not right. I know that's not right. Or like, what's 1 + 1? It says 6. That's not right. It wouldn't, but I'm just saying that's a hallucination. Yeah, tells you something that's not true. Correct. Okay, so let's go over prompting basics. What is a prompt? Like, what are we talking about in prompting? Okay, when we talk about prompting, right, or when we talk about like searching for something, right, you can go to Google and you can say, what's 12 divided by 4? Well, it gives you the answer. It's 3. Okay, that's cool, right? But it doesn't explain how it got the answer. It's just a calculator, right? It's just a tool. And so what we can do is, instead of that, we can use ChatGPT to be more in depth. So if you haven't seen it, and someone I'm sure will go find it right now, but there is a TED Talk by Sal Khan, who is, I don't know what you'd call it, the creator of Khan Academy, or the founder of Khan Academy. He gave a TED Talk recently about this and how tutoring is a big predictor of outcomes into educational outcomes, right? So if people have access to tutors, their outcomes are much better than people without tutors, right? And so there's this idea of like, now we can give a tutor to everybody because we have these LLMs. We can prompt them in such a way that they can act as a tutor in any subject that it's trained on, right? It needs to be have the data available, but things that it's trained on, we can give a tutor to everyone, right? And all of a sudden we get better educational outcomes that way. Is that true? Hasn't been proven. There's not data to support that yet. There is data to support tutoring, but like not these LLM tutors. But we're going to run with that concept, right? We're going to go. So we've got ChatGPT here. This is what the window looks like. And we have some, these are all slides, by the way. We're not actually typing stuff in here. We will in a second, but not here. So we say, ChatGPT, what's 12 divided by 4? The division of 12 by 4 is equal to 3, right? Well, that's a little weird that it said it that way, but it still got us to the answer, right? But we can do better, right? Because we can do that in Google. That's not cool. So, but this is a prompt, right? This is considered a prompt. We have prompted the model. We said, what is 12 divided by 4? And it told us it was 3, right? We give it an instruction, and that's a specific task that you want it to do. So in this case, it's division, right? And these are all terms that are used, right? So we have prompt, we have instruction. The instruction is in the prompt, right? Telling you what you want the model to do, okay? But I think we can do better than that, right? And in fact, I know because I may help make these slides. So we say instead, like, we don't want a student to just get the answer, right? Because that's not helpful. So instead we say, I want you to impersonate a math tutor named Dr. Division. Your job is to help a student learn the concept of division. If prompted with a request to solve a division problem, I do not want you to provide the answer, right? Instead, respond with concise content that you think can help the student learn the concept. So now we're going to prompt it with this prompt. And I saw a question really quick. I know we're kind of on a roll. I'll stop really quick. What's the difference between a prompt versus instruction? An instruction is just contained within a prompt. So you'll notice, and we're going to break this prompt that is here down. So this entire thing is a prompt, but there's actually several different components that we're using here that have names. So the instruction is what you want the model to do. The prompt is the entire thing, right? So in the first case, the instruction was the prompt, right? It was a very simple instruction. Here we have several different parts that we're about to highlight, right? So let's go look at those. So we have the instruction is this first sentence. I want you to impersonate a math tutor named Dr. Division. That is an instruction, but we need to give the model some context, right? So that's cool, but there's more to it than just be a math tutor, right? That'll give us okay results, but maybe it'll just give us the answer, right? So instead, we'd be more specific. We say, your job is to help a student learn the concept of division, so on and so forth, right? Don't give us the answer. Be concise. Like adding that kind of context to your prompt along with an instruction will give us much better results. So what do we get out of this instead of an answer? We get, greetings, young mathematician. You're Dr. Division. I'm Dr. Division, your trusty math tutor here to assist you on your journey to conquer the world of division. Let's dive right in. Dividing numbers, division, blah, 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 right? So now you see that the model is acting as a tutor, right? Which is super cool. So extend that idea out to any concept, which I've done a lot of concepts, like testing all this stuff out. It's pretty smart. Like it can do a lot of stuff. So if you're in school or anything like that, like a lot of people are worried, right? Well, ChatGPT can just give us the answer. Sure, that's totally true. But on the flip side of that, right, we can also turn it into a tool that can be used to further augment education, right? Further augment teachers, because not all teachers are created the same. Not all the curriculums are created the same. Not all school districts are created the same, right? So perhaps evening out these things just a bit using this kind of concept would be really cool. And I love this idea. I hope it pans out. I can't wait to see the data from it. So we also add, okay, we have all of that. It went off on this large tangent, right, about division. And we're like, okay, calm down, ChatGPT. Let's give it some more context, right? Try to keep it within the bounds of what we want it to do, right? And so this is the prompt engineering workflow. You give it something, you send a prompt, you get the result, you look at it, and you say, well, this isn't quite right. You go back and you edit your prompt, okay? So here we say, introduce yourself quickly, then wait for a question from a student before giving a response. Before it just spit out a bunch of stuff, right? Which, again, fine, but like that's not the point. So we tell it, we give it the context of like, wait for an answer. There, now notice how short its answer was, right? Hello there, I'm Dr. Division, blah, 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 blah. I'll do my best to guide you through. Let's dive right in. Full stop, right? No longer do we get that long explanation. This is great. So what do? Let's give it that initial instruction that we said. Now that we've given it some context of what it's supposed to be doing, we say, what is 12 divided by 4? And that's our input data now. So before it was our full prompt and instruction. Now this becomes the input data to our model, which we've now given context to and instructions on what it's supposed to be doing. So we say, what is 12 divided by 4? This is now input data. I know it's a bit confusing because it was the instruction before. Just realize that we've changed kind of what we're doing. And he says, it says, what a classic division problem. Instead of giving you the direct answer, let me explain, right? And it goes in to solve. You can think of dividing a group of 12 into 4 equal groups. Start by taking the total quantity, blah, 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 right? And it ends up giving us the answer a little bit, which is still a little disheartening. So a little more prompt engineering, right? Which is the workflow that we're looking at is needed to make sure that it doesn't give us the answer, right? It's still kind of giving us the answer and we don't want that. But still, it's way better than it was, right? It gives us an explanation of how it got there. And let me stop real quick. What's the difference? Oh, I already said that. What's the difference between what the context looks like versus the instruction? What's the difference between what the context looks like versus the instruction? Let me think. Difference between what the context looks like versus the instruction. Okay, I see what you mean. So the instruction is you're telling it what it should be doing. The context is putting. Okay, so someone said it the other day, and I thought this was a really good way to put it. And that is, think of when you're bowling, right? When you bowl, you throw the ball down the lane, right? So that's this action, right? But what you can do is to guide the ball. You could one way to do it would just be to get better at bowling, right? So you could say a better model if we're using this in the context of what we're talking about, or you could put up guardrails, right? You can put up guardrails to keep it from going in the gutters. And that keeps it on track. It's heading down the middle towards the pins and keeps it from from you just totally missing, which is great because you don't have to skill up and become a better bowler. Just put up the bumpers and all of a sudden you're a better bowler, right? And that means we don't have to necessarily update the model. We just need to give it good enough context so it understands what it's supposed to be doing and doesn't go into the gutter. Hopefully that's a good analogy. I really liked that analogy the other day. Someone said that. I'm not sure who. Otherwise, I would cite them. But we say here, right? Instead of giving. Oh, okay. So its answer, instead of giving you the direct answer, let me explain how division works so you can solve it yourself, right? So it goes on to explain that. Because we prompted it and gave it context to tell us how to do it, not just give us the answer, which is really, really cool, right? And here's the full explanation highlighted there in the middle. Now, right, we said introduce yourself quickly. We're going to add another context. So we say if your response includes examples, please include toys such as Legos in those examples. Right, so we can tell it, it was giving us all these things about quotients and all that, and that's really cool, but that can be confusing. Just like I just used an analogy for bowling, we wanted to use an analogy too. So we said use Legos, right, or toys such as Legos, right? And it says, hi there, I'm Dr. Division, blah, blah, blah. So it says the same basic thing, but also says, don't worry, I'll guide you through it step by step, using fun examples with Legos to make it more engaging and easier to grasp. And I'm going to explain a concept in just a moment that's called chain of thought, and we'll touch on that, but I want to finish this out. So notice that its example changes. Now to understand what 12 divided by 4 means, let's imagine we have a stack of 12 colorful Legos in front of us. Dividing Legos into 4 equal groups, blah, 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 blah. Giving each to a friend in round robin fashion. We repeat this process until the Legos are distributed. Now it's using something that's tangible. So by giving visualizations for the learner, by prompting it, giving it more context, it'll now spit back at us something that maybe is more relevant to the user. Okay, and so we continue down there. Imagine you have 12 stacks of Legos, blah, 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 until each group has the same number of Legos. Now think about how many Legos each group will have. Try distributing the Legos using the method I mentioned earlier. Observe how many Legos are in each group. By doing so, you'll be able to grasp the concept of division without explicitly giving the answer. Feel free to share your observations. Ask any further questions, right? So it's a back and forth that you're actually having as if it's a tutor, right? As if it's your tutor. And that's so great. And notice that it also didn't give us the answer this time, right? So the more context we can give, again, the more guardrails you're putting up to direct it to the right place, to get it to do what you want it to do. This is very similar to, for those of you that are coding, right? It's the same idea. The more code or more specific we are in our code, right, the more our outcomes will be deterministic, right? Sometimes we get weird bugs and all of this stuff, right? So we're always putting up guardrails to make sure that our outcomes are the same and deterministic, not just like, what the heck just happened, right? So we're doing the same thing, but this is more like just a different context and a different way to do it. So here's the conversation that we just had. Dr. Division, here's 12 divided by 4. So this is what happens, right? We prompt it, right? It says, these are the things it does. This is the input context. This is now after we've given it context and an instruction. And it all comes from the fact that we gave it this. Now these actually have names, right? So the user prompt is this, what is 12 divided by 4, right? That's after we've already given it context. We've already given it an instruction. The user prompt will be what comes after that. So if I'm a student and someone has handed me this math tutor, I can enter things, and that's called the user prompt. The system prompt is how you actually, is the instruction and the context that you've given to the model. And so these are all new terms, right? Not new term. I mean, user input has been a thing forever, but we have these different concepts of prompting. So the system prompt, the user doesn't see the system prompt. The system prompt has already happened before the user touches the model or the software or whatever, right? So you've tuned this system prompt in the background to ensure a good user experience for the user in the foreground. And that's that user prompt, right? So the workflow, right? We give it the user prompt, the system prompt, then we give it the user prompt, and we do some, what we can do is actually create a system, right? Where we have the system prompt already given to the model. The user, let me back up. If you're thinking about it in terms of code, in terms of a software system, the way it would work is a user gives us their prompt. They don't see anything else except them giving us their prompt. We combine it with the system prompt, which can then be fed to the model all at once. When it comes back out, we do some checks, right? We can check for formatting. We can check for hallucinations, relevance, like all of this kind of stuff. Also, we can do content moderation. So is it violent? Is it, does it contain swear words? Like these types of things exist out there that we can check for and give back maybe a pre-canned message if they do contain any of that or too much of that or whatever you decide on. To say, oh, this contained too much violence. I'm not going to tell you, I can't do that for you or whatever. And you may have seen this working with ChatGPT, some of these deterministic outputs that come back like, I'm an LLM model and I can't do that thing, right? That's what they're doing is these are kind of more guardrails to put up to make sure that the user can't just like turn your tutor into like the devil or something crazy, right? Like we don't want that. Okay, I'll stop to answer just some quick questions. Okay, how can we use ChatGPT to detect that someone used ChatGPT to create a response? It's a great question. It's not answered. I don't have a definitive answer for you. We're actually in the process of experimenting with that as we speak. Evaluation is something that is ongoing area of research. Many people are working on it. I'm working on it with my team at work. On how do we decide if it's a hallucination. Hallucination is not a solved problem, right? And so there's techniques, right? And so feeding it to an LLM and saying, is this right, did this come from an LLM, or is this a hallucination? I mean, that's to be determined. There's been some attempts at it that have been okay, but still an area of research. No definitive answer. What's the green flower icon? Oh, that's the OpenAI. I don't know. I think it's the OpenAI symbol or ChatGPT, but either way, it's one of those. And OpenAI created ChatGPT, just for those that don't know. Yeah. Oh, there we go. The logo for ChatGPT. Next thing. Okay. How this is different from IBM Watson in responding to a query. Medicine law are used on Jeopardy. Yeah, so that's a good question. So the difference is that it was trained to do specific tasks on a specific knowledge, right? Like you fine tune a model to do a specific task. So for Jeopardy, it was trained to do question and answering, right? So there's a question, it responds with an answer, and it fine-tuned on tons and tons of data, came up with that response, right? Or in terms of a query, right? You train it on medicine or law or whatever, and it gives you a response. And that response might be, or it's whatever, right? In this case, what's weird about ChatGPT or crazy is, first of all, it's trained on way more data. The second thing is it's one model. Well, GPT-3 was, GPT-4 is not, but nevertheless, and it gives us much more robust results in terms of instructing it to give you responses in certain ways, or be a certain thing, or do a certain thing. There was a lot of code on the back end of Watson that directs answers to specific places, right? And I don't know where it's at now. Maybe it's different now. But in terms of ChatGPT, it's different because you can ask it anything, right? It doesn't have it wasn't trained on this data and this is the only thing you can ask. Now it was, right? So through 2021. But there is this thing can speak Italian fluently. This thing can speak, I asked it, give me something in Russian. Just spits out stuff in Russian, right? And I've asked people who speak Russian or Spanish and all of this stuff, it just knows. It wasn't trained to translate. It wasn't trained to speak Italian. It just knows it because it has the data, right? Because it just has it and it knows what you're asking, right? We're not training it. It does all of the things. It's not just one thing. It can answer questions. It can be a tutor. It can produce code. You can have it write a program, right? Is the program good? Debatable. You might have to do some prompt engineering, but you can get some good boilerplate code out of ChatGPT. Can Watson do that? I don't know. Like there's just a huge leap that's happened where we are able, the code is it's no longer code. We're actually giving it natural language. So for instance, there is something that came out from Databricks where you can take a data frame or a SQL database and you can ask a question about it and it will give you an answer. And I'll show you what a system like that might look like here in a minute, but that's crazy. Instead of writing SQL queries, you just say, hey, what's the most, right? What was our highest gross revenue, or what year did we have the highest gross revenue? That's all you ask it. It'll go create the SQL query the database, and get you the results without you having to do anything, right? You just ask it that question. So these models are much, much more capable of understanding natural language than ever before. So that's hopefully answers that question. I could go on and on. This is a very exciting topic, but anyway, I'm gonna keep going. We'll circle back on some of these questions. I just want to make sure we get through a lot. We have quite a bit more. I'm probably, as usual, a little ambitious with this. So let me just. Okay. So we'll skip ahead. Now we understand user prompt. We understand system prompt, right? So you said I wanted to impersonate, right, a tutor named Dr. Division. That's your instruction. We've kind of gone over this. That's your context that we gave it. The input data is there, and then there's your output indicator, right, for your response. So what you're saying is now output your response as a JSON. We're like, no, I don't give it to me in plain text. Give it to me as a JSON. It's better that way for me, right? What's it do? It just gives us a JSON object. Like you didn't tell it how the JSON object looked. You didn't tell it what JSON is. You didn't do any of that. You just said, give me a JSON object for the response, right? Oh, okay, I guess you did. You know, called answer should be the correct answer to the question. The second attribute called response. Okay, so you did tell it keys, but nevertheless, you didn't tell it what JSON is. It just knew what JSON was and it output it as such, right? So now you start to see, if I'm a front-end developer and I'm expecting a response from an API, right? As a user inputs text, right, into my UI, it goes and sends a request to the backend, and all it's doing is giving that user and the system prompt over to the model. The model will output the JSON object, and you would just check it to make sure it's formatted correctly, and then send it back to the front end. And so that's kind of what these systems are starting to look like. We see we got the answer is 3, we got the response, and so it starts to become more powerful than just a chatbot. It starts to become a coding buddy. It starts to become a part of your software, right? It's outputting useful things that you can use in other components of your software that are not, right, generative AI. They're actual code and logic that needs to happen in order to produce some result. ChatGPT, you're going to keep trying to put it into a bucket. I would encourage you not to do that. I see this question, is ChatGPT a type of low-code, no-code platform? It's everything. It's whatever you want it to be, as long as you can prompt it to be that thing. Let me give you an example. When ChatGPT first came out, it has a lot of guardrails now. But when it first came out in December and I started playing with this thing, my first instinct was, hey, can it predict Bitcoin prices? And then I started to wonder, how could I get it to understand what Bitcoin is? Because it was only trained with data from 2021 up through 2021. So how do I get it to predict tomorrow's Bitcoin price? Right? Well, I asked ChatGPT, hey, turn yourself into a Linux terminal. It did that. And I said, only accept Linux commands and only run those commands. It did that. It became a Linux terminal. But the weird thing is it's imitating a Linux. It wasn't actually a Linux terminal. It was just outputting what it thought a Linux terminal should be, which was very good. Then I told it, act as if you have 6 V100 GPUs networked together and output what that would look like if I was querying, if you're familiar with GPUs, NVIDIA SMI. Give me the output from that, which shows all the specs on the GPUs. It showed me all the specs on the V100s. Then I told it to train a deep learning network utilizing data from these specific sources, blah, 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 right? Went on and on. I ended up getting it to output the code for a model, a deep learning model, to predict Bitcoin prices. Well, it was an ensemble. We had a whole bunch of different files. It created all of that. But did it? Or was it just imitating what it thinks it should be, right? And so what I did was I said, predict it within a certain confidence interval, right? Give me 95% confidence interval around that prediction. And I did it every day. I just kept doing it, right? I was like, what's it going to do? Predict it tomorrow. Predict it tomorrow. It was good. I'll just say it was good. You can't do it anymore, but it was good at the time. That was mind blowing for me. So it's whatever you can imagine, really, right? But now they've put up many guardrails, so it can't be whatever you imagine anymore. But man, it was really fun when it first came out to really go hard and push the boundaries of what it's capable of. Anyway, so prompting basics, right? Oh man, okay. I got a couple more things and I'm going to go back and answer a bunch of questions. We're going to talk. It's going to be really fun. Okay, prompting basics recap. A prompt is an input into an LLM in an application sense. What is sent to the LLM, the system prompt, can differ from what the input by the user is. Right? So user inputs something into the front end, but then we might insert that into a system prompt to give the model more context when we send that over so that we get an output that we want the user to see. Okay. And so a prompt can include specific instructions. We talked about that, 12 divided by 4. It can be context. Right, act as a tutor. It can be context. So, you have to explain the answer. Don't give me the answer. Use Lego blocks, blah, blah, blah. Input data, right? So the input data is what's coming in, right? We can use any kind of input data really we want. In this case, it was the user input. and information on desired output to achieve desired results. So when the output comes out, again, we can do that content moderation. We can look and make sure that it's formatted correctly, right? Like into a JSON object or maybe a YAML file, like whatever you want. It understands all of these things, right? Just tell it what you want and it'll give it to you. Again, with some engineering, prompt engineering, right? Whew, okay, let's talk about prompting techniques. And I'm going to circle back. I just want to zip through this, you guys, and we'll talk, just answer all these questions because there's probably a bunch of great questions coming through. So there's a few different prompting techniques. One is called zero-shot learning. Zero-shot learning refers to the ability of a model to just interpret and respond to prompts it's never seen during its training phase. So, and that's not exactly true. Like that's what it says, but like maybe it has been trained like on, it's seen somewhere in the data like 12 divided by 4 or something like that. But I can show you some like zero shot, like summarize this text or something like that, and it just does it, right? Like, so you can tell it one instruction, do this thing, and then it does it, right? There's no need for labeled examples there that match the exact prompt, right? So that's traditional machine learning, where it would need to have been trained to do a thing, right? ChatGPT is not trained to like summarize or speak in Italian. It just does it because it understands what you're telling it, right? And so leverages learned knowledge to generalize to new unseen tasks, and that's the power, right? It doesn't have to have been trained on a specific task to achieve a specific task. I'm going to show you this in a second. Hopefully it works out okay because we're going to do it live. But it's ideal for scenarios where training data for a specific task is sparse or unavailable, right? So if you don't have the data, which has been a huge barrier. So just to give you context, to train a machine learning model, you have to have the data. No data, no cigar, right? Like you can't just train some model to predict Bitcoin prices and then tell it to classify pictures of chairs. Like it doesn't, they only do the thing that you trained it to do, right? But ChatGPT, it just kind of does whatever, right? Like give it some stuff and it'll tell you some stuff, and it doesn't matter really what the context is. It doesn't do images quite yet. I know Google's Bard and stuff, they're experimenting with images and things like that. But like overall, there's other ways to go about that, I guess I'll say. But in terms of text, it's very good at it. We're going to look at a few-shot learning example here in a second. So few-shot learning involves providing the model with a few examples at runtime to guide its understanding of the task. So like, in fact, I'm just going to go to it. I'm just going to show you. It's going to be awesome. Okay, let's do it. So I have a premium subscription. We're going to show ChatGPT 4. All right. So let's see. Classify the sentiment of the following sentence. Okay. I don't like the rain. Negative, because the speaker is expressing dislike, negative sentiment towards the rain. That's cool. So let's say here is an example of sentiment classification. And honestly, you guys, it might get it right because GPT-4 is ridiculous. So I'm going to try and get it wrong, but I can't promise that it's going to work. So let's see. Sentence, right? We'll give it a sentence that says, we'll use that same example. So I don't like the rain. Okay. And then we'll say sentiment is negative, and then we'll give it a separator. These are all prompt engineering things, and I encourage you to go, I'll give you some resources to look how to do this, but so sentence, the sky is blue, right? And sentiment is what? So we leave it blank. We've given it one example of what we want it to look like, and then we prompt it down here, right? So we've given it an example. Let's see what it does. It's probably going to get it neutral. Okay. So ChatGPT 4 is really good, you guys. It's not how it used to be like 3 months ago. Used to be, but this is the idea of few shots. So you could say we could do something different, right? Like, so we could say because it's going to get these ones easily. I wish I had a better example that would trick ChatGPT 4. I just didn't have enough time to figure out how to trick a giant language model. Let me see. So let's see. We can see, we'll say this one, sky is blue is neutral. And let me see if we can trick it. Sentence is going to be, what is wrong with ChatGPT? Let's see what it says. I don't even really know what that is. I'd say it's probably maybe negative. Let's see what it says. Negative, yeah. Sentence, and then gives us an explanation. And I could have done this better, right? If I had said only, oops, if I had said like this, where I say like only output the sentiment using the structure shown. See if it gives us negative. It only gives us the output. Well, I can play with that a little bit. So you can see like ChatGPT 4 is super good. Sometimes the models are not as good and you need to prompt them. But ChatGPT 4, to be clear, is also very expensive. So where this stuff comes in handy, and this isn't a very good example because ChatGPT 4 is awesome, but you pay for it, right? So a premium membership for ChatGPT 4 is $20 a month. But what if I need to integrate this into a system? Well, OpenAI has an API endpoint, but they charge by what's called a token. So like you can think of tokens more or less as parts of words, but that really depends. Punctuation changes that a little bit and whatever. So like when they're charging per token, if you're, taking in, there was some statistic that I saw where it was like, Open Table or some big company like that was taking in N number of sentences or reviews every day. In order to get ChatGPT to like summarize those things and send them back to you, like the cost of that token, and they based it on the average number of tokens, it would be like $45 million a day to use ChatGPT to the API endpoint to like do the task that they wanted to do. So like sometimes ChatGPT OpenAI isn't the answer. You go get an open source model. It's not as powerful, which you can either fine tune to your task, or you can try to prompt it with few shot like this, right? And sometimes you get good results and you don't need, it's free to use open source models. And where can you get open source models? There's a place called Hugging Face. And that was what I was trying to prove here, but ChatGPT 4 is amazing and I can't trick it. So I apologize for that. But if we go to here, this is Hugging Face. Hold on. I'm going to drop this link in the chat. I'm not trying to share anything, but that's Hugging Face right there. You can use Hugging Face. It's a repository for open source LLMs and data sets that you can use to fine tune. You can use to prompt, and they have an NLP course on how to use their system to do that stuff. Can ChatGPT be used to create Cliff Notes summary of a book or technical concepts? Sure. Yeah, totally. Absolutely. Like the thing is you are limited, right? There's a limit to the number of tokens that a certain model can accept, right? And so let's go back. I'm going to talk about this third thing. Okay, so yes, you could have it summarize, Romeo and Juliet because it knows Romeo and Juliet. But if there's a book that it doesn't know, you can't just shove a whole book into the chat, right? It has limits on how much text it can actually accept. Tokens is what I mean. Sharath mentioned that it's not worth $20. I disagree, but that's okay. Because what you do get for $20 is the most up-to-date model. If it's free, it's only trained through 2021. But the models that I get to use, because I pay for it, both GPT-3 and GPT-4 are trained with data all the way up through like May 2023, right? Like May 21st or whatever it was. And they update it every month. So you get access to the latest updated model with the latest data. So that's the other thing to consider. It's not just, oh, you get access to GPT-4, you get access to the latest models, which gives you better performance and more relevant results, depending on what you're doing. If you're looking to summarize Romeo and Juliet, maybe not, but like if you want current data, like who's our current president, right? Well, if you have the model from 2021, no, don't say sorry. Yeah, I just want to throw that out there, not because I don't want people to be deterred by $20 thinking they don't get much. You actually get a lot. So if you ask the model for free, the free model, who's the president, what's it going to say? Well, it's going to say Donald Trump. Wait, 2020? Okay, maybe not. But like, let's take something else, a representative, right? For instance, right? But the representative might have been reelected. There might be a different representative now for some state or something, right? And so it'll give you current results if you ask it now versus back in the free model from 2021, because it doesn't have any knowledge of what's going on. Anyway, updated models, that's my pitch for why $20, I think it's worth it. So few-shot learning is like, we give it examples, and it didn't really work like that well there with GPT-4. It's a very powerful model, and it's probably not gonna work, but for a less powerful model, these are great techniques to use. And again, I'll probably do like another presentation someday of like how to use like Hugging Face and like LLMs for free, right? To create like actual software. But for now, GPT, right? And uses several examples. And we actually have access, by the way, if you go to OpenAI's website, you have access to the API. It does cost you, but you have access, right? And the charges are pretty transparent in terms of tokens. So few-shot helps the model to generalize and respond correctly to new and similar prompts, right? So if we give it sentences from then on in, it's just going to classify the sentiment, classify the sentiment, classify the sentiment. And we gave it instruction. We gave it context there of what we wanted it to do in terms of sentiment. And it's useful for limited task-specific, when limited task-specific data is not available. Again, this idea that we don't have the data, but if we just tell it what we want it to do, maybe it'll be good at it. And this is really powerful, you guys. I can't talk about like a lot of what we're working on, but I'm telling you right now, this is just scratching the surface of what these things are capable of. It's pretty insane. And so what companies are interested in right now, let me say why this is, what the ROI on this, right? And is it okay if we go a little bit over? I'm almost done. Is like, so we can get
questions. I don't have anything after this, so take your time.
Okay, great, cool. So the thing that companies are interested in is, okay, great. It has access to public data or, data that's available, right, through APIs and websites and all that stuff, but it doesn't have my data. My data is sitting in the cloud. It's private, right? ChatGPT doesn't know, or GPT-4, I should say, that's the model. ChatGPT is the chatbot, GPT-4 is the bot. It doesn't understand, right? Like, my sales numbers from last year. I can't just ask it, give me my sales numbers from last year, right? I can't even give it like through the window or through the API, right? I shouldn't say the API. You can't give it like ask it through this chatbot, right? Like and say, hey, give me all ChatGPT, give me all my sales data, or who was my top performer last year, or whatever, right? But what we can do is use something called retrieval augmented generation, and this is super powerful. Right? Retrieval augmented generation is the idea. Remember when we said we can put the user prompt into a system prompt and then send that system prompt to the OpenAI GPT endpoint or to OpenAI, right? Through ChatGPT. But through the API, we can do the same thing. We can send it a system prompt, but we can inject content into that. So what can we do? We can combine retrieval-based and generative AI models. Okay, so this is when you need it to talk about your documents. You need it to talk about existing data that it isn't trained on and doesn't have knowledge of because it's maybe behind, in your company. So here is a diagram, right? So again, we have the prompt and query come in, right, from a user. But before we send it to ChatGPT, or I should say, I keep saying ChatGPT, GPT, right? We actually go this way first. And what we do is we query our knowledge base, our knowledge sources. That can be PDF documents. It can be SQL databases. It could be whatever you want, whatever's sitting over here, right? That you've put that it has access to. And this isn't GPT does not have access to it. These are different systems. So think in terms of Azure, cognitive search is their a search tool that you can send, say, a bunch of PDFs to. It will index them and allow them to be searchable. So now what we do is we take the user's query. We first send that over to the search to search for relevant information related to their query through something like cognitive search, which will search, again, guys, PDFs, text documents, databases, whatever you've indexed back here. I keep waving my hand like you can see what I'm saying. Back here, right, is what now the knowledge that you can actually inject into your prompts so that GPT will have access and understanding. It will have context, which is what we're doing. We're doing context injection, right? So now that we got the relevant information, we come back here. By the way, this is from Amazon. You can do this in all clouds, you know, whatever. But I'm just using this diagram from Amazon, but it would be the same in any cloud, right? They all have kind of a search service. You can think even the Elk Stack, right? Elasticsearch and things like that, right? Whatever it is, you query it, the knowledge source, you bring the relevant information back, right? That then gets injected it goes into the system prompt along with the user's query, right? So we design a system prompt to be able to accept the context from these knowledge sources. We send all of that over to GPT. And then, so now you can start to ask questions about your data. They call it chat with your data, right? So you can just say exactly what I was telling you. You know, who were my top sales performers last year? Well, if you have your sales data over here, it literally will just it'll send it to that search database. It'll search for all the things it needs from, you know, that are related to the sales, bring it back over here, and GPT will put it into whatever context you put in your system, or put it into whatever form you defined in your system prompt, whatever output you define, and then send that back to the user. So the user doesn't have to know SQL anymore. They don't need to learn Apache Spark. They don't need to know any of that. They just need to know how to ask questions, right? And because GPT also knows different languages, it doesn't matter if it's in English or Portuguese. It'll understand and give it back to you in that language, clean and good sentence structure. Like, it's wild. That's assuming you want it back in that form. If you say, give it back to me in the form of a JSON, that's different, right? But like, anyway. Okay, RAG, retrieval augmented generation. This is the thing that companies are chasing after and trying to figure out how to do, okay? It's easy on the surface, not so easy in practice, believe me. Okay, conclusion, right? And references. Deeplearning.ai has released 5 short courses all about these topics. Prompt engineering, they're free, by the way. Prompt engineering, they've got system design, they've got LangChain, which is an orchestrator of prompts. So think Apache Airflow for LLMs. And also, there's one more I'm missing, something else. They've got, there's 5 courses available. I can actually go there right now because I have it. Have the courses. I'll tell you, short courses. Okay. And I'll drop this link right now so you guys can go check it out. Paste. All right, so ChatGPT prompting for engineers, building systems with ChatGPT API, LangChain for LLM application development, LangChain, chat with your data. They talk about what that looks like, and they use something called a vector database. I'm not even gonna go into vector databases right now, but that is something, that's a whole talk in and of itself. But like, so they talk about vector databases, how to use your data to, you know, design this chat with your data feature. And then how diffusion models work. So these generalized diffusion models, these generative models that are outputting images, text, like all of that stuff these days, they actually go through and teach you how diffusion models work, which is super cool. I actually haven't taken that one yet. It's on my list, but I'll get there. I always do. Okay. Oh, I forgot I had a slide on it. There you go. And then the prompt engineering guide. So there's a prompt engineering guide. I'm going to drop that one too. this is really, really helpful and kind of the go-to right now for people to learn prompt engineering, or as a reference. It's a Git book, right? That's consistently updated, which is super cool. Definitely recommend checking that out for all of these concepts and more. There's tons and tons of concepts to learn about. I only touched on the main ones. And I didn't even get into chain of thought reasoning and all of this stuff. I wish I had, but that's okay. We have limited time. Now I can't move forward in my slides. Oh, it's probably because I'm done. Yeah. So anyway, okay. That's a lot. I know that's a lot. I know someone has questions. We can go back up through if you want. On original.
Yeah, there were definitely a few questions. First of all, that was very informative. I just feel like I learned so much.
Good.
So let's see. Sher's asking which steps in the diagram constitute context. Context and injections, I mean. From the diagram you just shared.
Context. Oh, okay. Let's go back to that and I'll share again. Whoops, I stopped sharing. Sure. Okay, let's take a look at this. I'll make it bigger. Slideshow. I should have started from there. Oh, dang it. Will it start from there automatically? Is it smart enough? Okay, cool. It is smart enough. All right. Yeah, look at that. Probably an LLM. No, I don't. Okay. The context. The context is what we're pulling from our knowledge sources, so from our knowledge base. So when we receive the content from over here, and it gets injected into our prompt along with the query, right, to be sent to the language model. So the context in this case that we're providing is the content from these knowledge sources.
Got it. Thank you. And then someone just asked synthetic data, question mark?
Say that one more time.
Someone just asked synthetic data, question mark? Just maybe wondering if just so you can clarify on that.
Yeah, clarification would be good. Oh, maybe they're asking people to create synthetic data. I can speak to that. So yeah, so what's great, what's crazy, right, is that that we're realizing now is that yes, you can actually. So let's say because you need to do testing and stuff on this, which is another area of research. How do we test to make sure the model is doing the thing? What are the metrics that we're using? Things like that, right? And there's lots of different metrics. The simplest being accuracy, but it goes far beyond accuracy, right? We also want a measure of quality. So there's lots of quality metrics that we can use, including just sending it to an LLM and being like, is this quality? Right? But creating synthetic data, you can create synthetic data. So you can prompt it to tell you, give me examples of good and bad summaries, and you can few shot prompt it with a couple of summaries that or whatever, right? I'm just giving an example, but a few summaries that are good or bad, right? And then it will go through and generate other ones for you. So yes, you can get synthetic data out of this, which is great because a lot of times you have to wait for data, or you have to find data or find proxy data. Now you can get a lot of the data you need, good examples of data, without really having to wait, right, for users or something to get their queries. You could maybe get at least preliminary results based on what ChatGPT itself spits out. And I keep saying ChatGPT, what GPT spits out, because it may not be ChatGPT. Anyway.
Great, thank you. Also, I also put this in a note, but just let us know if you haven't answered any questions yet. Just restate it in the chat to make sure we get to it. But Jacob's asking when you were referring to Bitcoin, and you were talking about all the roadblocks that it has. So do you know if ChatGPT 4 or 3.5 have the same roadblocks in that sense?
I was really hesitant to mention predicting Bitcoin because I knew everybody was going to be You're like, cha-ching, like, how do I do this? All right, so there's been a lot of people out there, right, that have tried to predict the price of Bitcoin. And if you know anything about markets and random walks, this is not easy. There are entire investment firms that if you figure out how to predict Bitcoin prices, they'd probably hire you or at least buy your product, right? It's not a thing that we can do on our laptops. So if you're interested, you can go explore it, and I'm not discouraging you, but that's not an avenue I would recommend going down because it's kind of all for naught. Even if you could, you wouldn't have the compute power or the data to be able to actually like get decent results. I was surprised by the results I was getting, but now it blocks me and now it won't do it. So are there more powerful models? Yes. Will they predict the price of Bitcoin? Maybe. It's worth exploring. Go explore. Go to Hugging Face, look up a model, and go build me a Bitcoin predictor. And when you do that, feel free to send me the code so I can also cash in. I don't want to discourage people, but it is not a problem that's probably doable. But then again, it was giving me good results. Who knows? I mean, again, it was such a small sample size, you guys. I'm talking about like a few days it was giving me good results. That's not nearly enough to stress testing to say like, yeah, it was predicting Bitcoin, but it was within my 95% confidence interval. That's all I was saying. Yeah.
I should clarify, Jacob actually meant the API.
The API.
Yes. Not the actual chat solution.
No, it's not an open, right? Like you can't just do whatever you want with the model. No. They OpenAI specifically puts up guardrails so that people can't do specific things. It's very open in terms of what you can do, and maybe there's a jailbreak, right? But yeah, no. It's not just an API you can hit and tell it to give me the price of Bitcoin. Otherwise, I wouldn't be here right now. I'd have to buy my own island and be chilling,
All right, next question. Business-wise, can we or do we have LLM trained or a US patent database and have it create new patentable inventions or find related IP?
So talking about patents, like searching for patents, like, can you summarize that? Is that what they're asking? Like, US based? Do we already have an LLM trained on the US? I mean, that's the thing, you guys, is you have to get out of the old way of thinking about machine learning. We don't need an LLM trained on the patent database. You need to make the patent database a knowledge base to be able to do context injection into the model, do a few shot prompt, and it'll give you something, right? And really that problem is like, that's the thing everybody's wondering is like, can it create new inventions? These are all questions that are out there that are not solved. So if it's an area of research you're interested in, I encourage you to just go do it and find out. I don't have the answer to that, unfortunately. There's LLMs trained on all sorts of things, but I highly doubt it's trained on patents, right? It doesn't need to be. It probably has some data in it already that's already trained, like GPT or whatever. Again, you guys, we're talking 45 terabytes of data. There's got to be something in there about patents. Maybe not the patent database, but you can augment using RAG, right?
Got it. And then let's see. Is the future of LLMs about having specialized LLMs much like we have apps?
No, the future is not specialized LLMs. The future is still apps with integrated LLMs, right? Generalized models that are trained on such a large amount of data that we can create applications around them using them. And that's the point of prompt engineering. So we think less about specialized models. We think more, right, about how do I just prompt this thing to make it do what I want it to do. Now there's caveats to that, right? Like if there's simple things, like if you have enough data and you can fine tune a model to do exactly what you want, then you don't need prompt engineering, right? But with prompt engineering, again, with training these models, you guys are huge. the amount of compute that it takes to train these models is not within your grasp. And that's why we're using these models, right? You can fine tune them, but even that takes a significant amount of compute power. That's why prompt engineering is so fascinating for companies, because no longer do they have to foot the bill for all this compute. They just need to foot the bill for either the API or even a model that's free from Hugging Face. There's no model on Hugging Face that is yet as powerful as GPT or gives as good results, because GPT there's like, a bunch of geniuses over at OpenAI working on this, right? But there's people working on these models as well. But these models are much less or not much less, but less powerful, a little more. I don't know what the word I'm searching for is, but it's a little more difficult to get them to do what you want them to do, but they're also free, right? So you can see the ramifications. If you can get the prompt engineering right, you can give it the proper context, and you grab a free model and you're getting like ridiculous results like that, the ROI is astronomical on that, right? So you're not even paying for anything but hosting the model, which is not that much. A server does not cost that much. Hopefully that answered the question. I forget what the question even was, but I rambled.
No worries. Let's see. So are you limited to 35 messages of ChatGPT 4 as Jacob is, or do you have to use the API to get around that? And it goes on and says, I imagine creating my own simple React using API would fix the solution. Still, however, 35 messages every 3 hours seems arbitrary.
So here's the thing. GPT-4, so I'll give you the context. To host GPT-4 takes an insane amount of compute. It's quite to host the GPT-4 model that they're hosting takes a ridiculous amount of compute, right? It's costly, and so there's a limited amount of compute that's available to host these models, right? And the demand is so high that it actually, when it first came out, it was overloading their systems. Like things would break, you just wouldn't even be able to get in. Like I would reload like I was trying to win a prize, like just reload, waiting for it to just like let me in because somebody else just left, right? The systems are so overloaded, they had to throttle the amount of messages people could send and the amount of people that could actually access it at a time to be able to make it highly available, right? They were just so overloaded, and compute is so limited, it just wasn't possible, right? To have more than that. And actually, Microsoft just came out, and the API does not get around this. You cannot get around this. I know everybody always thinks it's a closed API, right? And so Microsoft actually came out and said, we are out of compute for GPT-4, and therefore do not rely on these systems for high availability. And I'll just say, GPT-4 is amazing, but you can get a ton of action out of GPT-3. You do not need GPT-4 to get significantly better results than you would get out of whatever, some fine-tuned model or whatever on Hugging Face, right? So don't feel like it's a ripoff. We don't get access to GPT-4. GPT-3 is ridiculous, you guys. Go use it. Plus, it's faster, right? So GPT-4 is very slow. So we've noticed, like when we did testing, right? It takes a long time sometimes to get responses, and can dramatically increase and slow down the rest of your system. So you have to think, what benefit am I getting from GPT-4? Maybe I have to do a little more prompt engineering to get GPT-3 to give me the results. But heck, I get unlimited. I'm never throttled, and it gives me faster results. So actually, I would argue that that's probably the better way to go, unless you have some very, very good use case to be using GPT-4. Someday I'll stop saying that.
I agree with that. I've been using ChatGPT 3, and for what I need, it's been pretty much doing everything I needed. That's why I haven't felt the need to get the Plus subscription yet. I was actually surprised to see a lot of people like the 4, just because I was like, what do you need it for? You can do it all for free.
Exactly.
But now I can see why. Also, this brings up something. So what do you mean by throttle?
Right. So that's that limit. I'm just talking about the limitations that they place on like your requests, right? So they throttle your request. It means that like, right, you only get 25. You're limited, right? So throttling, that's all that means. Sorry.
Got it. And then just a few more questions, just
Sure.
because we're a little bit over time. But let's see. So regarding the chart we have, the diagram we have up right now. So Sherry's asking what part of the diagram is called retrieval or augmented? Goes back to her original question when she was asking about.
Oh, I'm still sharing the diagram, right? Which part is called retrieval and which part is called, oh, I see, right. Retrieval augmented generation. Got it. So the retrieval part is retrieving the knowledge or the context from your knowledge base, right? And it's augmenting your prompt with that context to be able to give it more, but I use the word context way too much these days, but context, right? Give the model more context by retrieving knowledge from your knowledge sources. So it's a retrieval augmented generation.
Thank you.
Yeah.
And then also I'm going to reshare the presentation.
Okay, cool.
That you shared earlier here. Slide. And then someone's asking, so how do you write a book using ChatGPT? Read that someone wrote their grade thesis using ChatGPT and it was accepted.
Sweet.
I don't know if I would 100% recommend that. Maybe like change it up a little bit.
Copy and paste, baby.
I don't know if this is a good trick I'm giving everyone, but so you know how you can like type in your text, but then there are a lot of websites nowadays that can detect that you've written it out in ChatGPT. Well, in ChatGPT, you can type it right as if a human wrote this. And then I've actually tested this and it actually can detect it on some of these websites. So I can't see any other questions. Oh, final question. So as a junior developer working from a big break into the industry, how would you recommend I use ChatGPT? So interview prompt, tutoring, assignment help, etc.
All of the above. Like use it as much as you can. Like, okay, all right, let me give you this advice. As a junior developer, what you can do with ChatGPT is you can say, so I'll say it right now, write me the code for a deep learning model that, okay, we'll just be fancy. This is not real, guys. Do not copy this. Predicts the Bitcoin price, that predicts Bitcoin prices, right? I'm going to make it really general. It's not going to give us anything good, right? You could prompt engineer the heck out of that. Still probably wouldn't maybe give you something good. Oh, dang it. I'm providing, it's going to give us an LSTM. Okay. So here's an example. All right, here's the code. Right, I didn't tell it what data to use or anything like that, right? It's going to be like, who knows, right? What it's even talking about in terms of like what you're supposed to feed in and stuff, but because it uses some data, right? It says read in Bitcoin price. Oh, it's probably just time series data. So it's a CSV of time series data, right? So it just wrote us a deep learning model. It's an LSTM to predict Bitcoin prices, right? Is it good? Maybe. Probably not. But like it did it. And this code, a lot of this type of code runs, so wrap it in a fast API or wrap it in fast API endpoint, right? Oh, notice I said wrap it. I didn't even tell it what it is. So by the way, remember that this has memory too. So it remembers the context of the conversation you're in, right? But look, there it goes. So now you have a post endpoint that you can send requests to give it, right, whatever, I don't know, to get the Bitcoin prices, right? An asynchronous endpoint. I didn't even tell it to do that. That's kind of nice. Anyway, so back to your question. As a junior developer, don't do this. Don't go to ChatGPT and tell it to output all your code. The problem is you don't know if this is good code. You don't know if this is good practice. Notice actually that it isn't. I don't see any comments here. I have no idea I have an idea of what this is doing, but like somebody coming in would have no idea what this is doing. right? This isn't, modularized in any way. You can tell it, add comments, modularize, like do all of that stuff, right? Maybe GPT is going to replace all of our coding jobs, right? But for now, it's not. So if you're learning, don't have it go produce code. It's so easy to go have it try to do that, but learn it on your own. Learn all the basics. Learn to read documentation, learn your data structures and algorithms, learn web stuff, right? Like how it works, protocols and so forth. Like learn this stuff on your own. Then you use a tool like ChatGPT. Give me some boilerplate code, because sometimes like this fast API, this is like the same almost every time, right? Like it's like, give me a boilerplate code for a fast API app, or give me this or that. And there's also GitHub Copilot. It's really great because that'll help you with boilerplate code and writing code. I'm way more productive with GitHub Copilot. I use it every day, right? Which is another thing that it's an extension that you can use that helps you code. You can use it in Vim, you can use it in VS Code, PyCharm, like whatever you're using, right? And it's specific to coding. So they did fine tune that one on like GitHub, right? But as a junior developer, try to do things on your own as much as possible. And that's what you say to all students these days, right? Okay, great. They wrote a book, but like once you get out in the professional world, like my company restricts us. We can't use ChatGPT at work, right? On the VPN. So it's not available. So if you didn't learn it and you get a job based on ChatGPT, you're going to be really sad when you get to the company and you can't use ChatGPT to do your work because you didn't learn anything, right? So learn it on your own. That's the best advice I can give. Use this as a tutor, as whatever, but make sure you're just do your own work, right? It'll pay dividends down the road.
Great. I think that's a great way to end it. Thank you so much. So there's a few other questions in the chat. I'm going to link your LinkedIn, and everyone who wants to follow up with anything, feel free to contact Chris on LinkedIn. Also, again, we are recording this and posting it on our YouTube channel, and you can watch this and all of our previous talks on our Tech Talk playlist. And any final thoughts, Chris?
No, like I guess my final thought is just like, I've seen a lot of great questions here, and like, I don't want to be discouraging to anybody. So if you have an idea, LLMs have provided us an opportunity to create incredible things without as much work as it used to take. So if you have an idea, I say go create it, make it open source, and let other people contribute, and maybe it'll grow as a project. But go like use these things, because it is amazing. It's so amazing what you can create.
Awesome. Thank you so much for another amazing Tech Talk. I really appreciate it. And thank you everyone for joining us. No Tech Talk next week as of yet, but I'll let you know. But I hope you guys have a happy Friday and a great weekend. And thank you again for joining us. And thanks again, Chris.
Cool. Absolutely, Regina. Thanks, everybody.
Yep. Bye, guys. Thank you.